The electrical distribution panel is the lower left part of the overhead 4P panel. Noting that the electrical distribution system is split left and right. Normally these two systems are not connected. When we plug in a ground supply plug, this will automatically supply the ground services bus bar, but will not connect to the main bus bars until we select the master switch. Note the internal supply to ground services is showing disconnected, and the ground supply plug connection is showing connected. Before we connect the ground supply to the main bus bars, we're going to do an internal battery voltage check. This requires that we turn on the batteries and then select internal on the master switch. This will connect the batteries to the main bus bars and allow us to check the battery voltage on the 2 voltmeters. The left battery voltage is checked on the voltmeter, which is part of the voltammeter on the generator control panel. The tail battery voltmeter is connected to the tail battery only when the master switch is at internal. The right battery voltage is measured on the right battery voltmeter, which is on the right generator control panel. With the master switch at internal, the ground supply is not connected, the 2 batteries are connected to the main bus bars, and the coupling contactor is showing disconnected. Note also here the essential services are connected. When we select external, the batteries have disconnected, the bus bars have coupled, and the ground supply plug is now connected to the right main bus bar. If we do not have a ground power unit, we can supply ground services only using the right battery by selecting the electrical master switch to internal. This supplies the ground services from the right battery, but note we did not use the right battery switch. The indicators also show that the ground supply plug is not connected to the ground services. This selection allows servicing of the cabin when a ground power unit is not available, with minimum drain on the batteries. If we wish to go to full internal supply, we would switch the batteries on. For normal internal supply, we'll select the batteries on and then select internal, connecting the batteries to the main bus bars. Note the battery indicators showing connected and the coupling contactor showing disconnected. Also, the ground services indicator showing connected to the right battery and the external supply indicators showing disconnected. Note all the indicators are showing vertical green. This is the normal flight condition. Any horizontal amber indicators would indicate a fault condition. At the end of a flight, when the aircraft lands and taxis in, the power supply will still be internal But when the aircraft parks and the ground crew plug in the ground power unit, this will automatically change over the supply for ground services onto the ground power unit. This allows the pilot to then select power off or to external before he leaves the aircraft. This auto changeover does not occur on the latest 300 series aircraft, which have a modification to the ground power supply. The Essential Services bus bar is normally supplied from its own main bus bar, but it will take its supply automatically from the opposite main bus bar if its own main bus bar loses supply. For example, here we have switched off the right battery. This transfer function can be tested by pressing the Essential Services indicator, and then return to its own main bus bar by pressing the indicator again. The AC system uses DC supplied static inverters to create 115 volt, 26 volt and 5 volt AC 400 Hz. The 115 volt and the 400 Hz is displayed on a volts and frequency meter on the top part of the distribution panel. The left inverter supplies the left AC system. The right inverter supplies the right AC system, and a standby inverter can connect to either AC system if one of the other two inverters fails. In this example, we have switched off the right battery to kill power on the right main bus bar. The same transfer condition can be demonstrated by switching off the inverter. This is done by pressing its on-off indicator switch. Note the right AC bus is now connected to the standby inverter, and the right inverter indicator is showing off. Press the indicator again to reconnect the inverter to the AC bus bar. Failure of the standby inverter is shown by the green line disappearing and off appearing on the standby indicator switch. We can connect the left AC bus bar to the standby inverter by switching off the left inverter switch. If there is a second inverter failure, the standby inverter will only supply the first bus bar to fail, so the second failure side will lose supply, demonstrated here by switching off the right inverter. If the left system subsequently recovers and the left inverter reconnects to the left AC bus bar, then the standby will transfer across to the failed right-hand system, and both our AC systems are now functional. And finally, we recover the right AC bus bar onto the right inverter. When external power is selected, the tail battery voltmeter disconnects from the tail battery. This is to prevent the tail battery from discharging slowly while the aircraft is parked for maintenance with external supply connected. Therefore, the tail battery voltage check must be made with internal power selected. The shedding bus bar switch is normally at emergency while the aircraft is parked. This is because the generators are not operating. If the switch is selected to override or to normal, the shedding bus bar will disconnect. The switch will be selected to normal during the preparation for takeoff, after the generators have been switched on, after the engines have been started. But for ground use, the switch is always left in its emergency position. This allows power on the shedding bus so that we can test the anti-icing services pre-start.